Okay, so today we're doing inverses and determinants. We need to have this so we can solve systems of equations. We're going to be solving systems of equations using the inverse, so we need to be able to find them. So we're going to work on that today and tomorrow. I may change my mind and tomorrow we just do 10-5 because I think last hour got it after notes. They were good. So I don't know. We'll see. Because you're gonna have to keep doing it to solve the system, and that would be better than waiting until later in the week to go. But I'll find out tomorrow. Because it's vectors, and I'll leave that for physics. Okay, we don't have the time right now. If we were ahead of schedule or on schedule, I would do that. Okay, so an inverse matrix of a 2x2 matrix A, B, C, D is the matrix W, X, Y, Z such that the product of the matrix is the identity. The product of the matrices is the identity matrix. 1, 0, 0, 1. We talked about that identity, right? Identity is something I can multiply the matrix by and I get what I started with, correct? So I need to do this product and get this. So that means I would have to take A times W plus B times Y, that would be my first term, right? And then A times X plus B times Z. And this would have to equal 1. Sorry, I forgot to put it. That would have to equal 1, right? And this would have to equal 0. And then C times W plus D times Z. Nope. Y, not Z. Would have to equal 0. And C times X plus D times Z would have to equal 1. I'm just too close, so I would need to figure those out. Now, once I had A, B, C, D, I'd have a system right here. This would be a system of equations with unknowns as W and Y, and we know how to solve systems of equations, right? And over on this side would be unknowns of X and Z, and you would solve those. So we can do it this way, and we will. We'll do one this way, and then I'll show you another process that's much easier. So we're just going to take them, multiply them together, and we know what they already should equal, and we'll be able to solve them that way. Guys, let me know when you're good.
Is that dy at the bottom? Why is it always...
Yeah, I put a Z there on accident first.
Wait, why is it the brackets? Well, not the brackets, but
The curly
yeah.
is because this is a system.
Should we have to put those?
Yeah. No.
Should we put those?
No. You guys are...
So only the brackets get put?
Yes.
You're not going to do it this way anyway. You're not going to do it this way. I'm going to show you how, like, if I don't give you a formula, how you would have to do it.
Well, I'm good.
Okay. Everyone else?
Yeah.
Okay. So, what is the inverse of 2, 1, 3, 0? So, we have to multiply that times W, X, Y, Z, and get what?
1, 0, 0, 1.
1, 0, 0, 1. So that'd be 2W plus Y equals what? 1. That has to equal 1, doesn't it? Okay. And 2X plus Z has to equal what? 0. I don't know why I made my bracket so huge. Didn't need to, did I?
Yes, you did. I don't think you did.
Okay, and then 3W equals, well, plus 0Y, which would be 0, right? Equals what?
0.
0. And 3X plus 0Z equals what?
1.
1. So this is why I had the brackets, Because this is now a system of equations on the left, correct?
Yeah.
Yeah,
And this is a system of equations on the
right.
right with two variables, two equations, right?
Yeah.
Okay, well, there's different ways we could solve systems of equations. How would you like to do that? We can do substitution, elimination, graphing, Gauss
Substitution.
formulation. Yep, that's the easiest way. Because what is W?
Zero.
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 Because I have 3W equals 0, W would be what?
Zero.
0. So if W is 0, I plug that back in.
Zero.
So 2
Y is
times
one.
0 plus Y equals 1. So Y is
One.
1. Over here, what's X?
Is 1/3.
1/3.
Yes.
So that would be 2 times a third plus Z equals 0.
What's
So 2 times a third would be 2/3, right?
Yeah,
And then I would subtract it over.
yeah.
Yeah? Is it? How would I solve that? Okay, so Z equals what? Negative 2/3. So we're going to call this matrix A. Just, I didn't name it, did I?
No.
So A inverse, 'cause that's what this is, right?
Yeah.
Okay, what's W?
Zero.
0. What's X?
1/3.
What's Y?
1.
And what's Z?
2/3.
So if I take this times the original, what should I get?
That.
1001. Okay. So that's a lot of work, right? And this wasn't too bad because we had these two things helping us out, right? If we didn't, we'd have to do more work, wouldn't we?
No.
I'm confused about 3W equals 0.
Because 0 divided by 3 is 0.
I just didn't.
Your brain just wasn't going there. So that was really nice because I didn't have to add, subtract anything over, and then divide it, did I?
No.
Or I didn't have to multiply by something and eliminate.
How is it 1 for 3W equals 0?
No, Y equals
She didn't.
Y equals 1. W equals 0. Then I plug that into the original. So 2 times 0 plus Y. This would be 0. So Y equals 1. Okay, but that's a lot of work, right?
Yeah.
And this is a lot easier than it probably would be if I did it this way every time. And you guys don't want to do that way every time, do you?
Yeah.
Okay, so I'm going to give you a new rule. And you need to have it all down. So, for A equals ABCD, the determinant of a 2x2 matrix only. Got me? What I'm showing you only works for a 2x2 matrix. Am I clear? If you get a 3x3 or a 4x4, you have to add columns and do kind of the same thing, but we're not going to do that. Okay? We're doing 2x2 and that's it. Okay, so the determinant of a 2x2 matrix is denoted DET, right here. Okay? So DET, what does DET stand for?
No.
Determinant of A equals A times D minus B times C. Every single time on a 2x2 matrix. First diagonal minus the second diagonal. Got it? The inverse of A is denoted A inverse, just like inverse of like F, right? When we did F inverse, we did -1. It exists if and only if. That's an IFF, if you want to shorthand it. If and only if the determinant is what?
Not equal to 0.
Not equal to 0. If the determinant is 0, does a matrix, inverse matrix exist?
No.
No. So before you start this process, guess what you're going to find to know if you need to continue? The determinant. plus you use the determinant in the process. Okay? So once you've established that the determinant isn't 0, A inverse equals this right here. A inverse equals 1 over the determinant of, so this is a scalar, right?
Yeah.
D minus B minus C A. So what happened to the matrix A, B, C, D to get D, negative B, negative C, A?
The determinant.
The main diagonal did what? It
Flipped
interchanged
around,
places, yes.
And C and B went all negative.
And then you
like-
took the negative of C and B. That is how you find the inverse. Wouldn't you rather do this than what we just got done doing?
Sure.
Yes. You're doing the same thing, but a lot quicker, and your brain doesn't have to think. It just uses the formula.
But it only works with 2 by 2.
This way to find A inverse works for more than a 2 by 2, but the determinant, the way we're finding the determinant, only works for 2 by 2. To find inverse of a 3 by 3, you still take 1 over the determinant, and okay, this pattern changes too. The patterns change because you're going from a 2 by 2 to a 3 by 3 to a 4 by 4. So what I'm showing you explicitly only works for a 2 by 2. And figuring out the generation of the new pattern is not as easy as just doing one more thing. More involved. Everyone got it down? Because you need it. What you should have on your paper is A equals A, B, C, D. Determinant of A equals A times D minus B times C. If determinant is not equal to 0, then, what does that mean right here?
The inverse of that.
In A inverse, or the inverse of matrix A, is 1 over the determinant of A, D, negative B, negative C, A. You have to know that.
All of it?
Yep, that was just what was on the other side. So if you wrote it off the other side, don't rewrite it. But you have to know that. You rewrote it again. Okay, so 1, negative 1, negative 1, 1. What do you guys want to name this one?
B.
B? Okay, so the DET of B. I expect you to have that written on your paper. What does DET stand for?
Determinant.
Determinant. You can't just write two numbers subtracted from each other and expect me to know what you're doing. Got it?
What do you mean?
You gotta label your work. Okay, so how do I find the determinant? Main diagonal, the product of the main, subtract, right?
Yeah.
So 1 times 1 minus a negative 1 times a negative 1. So that is 1 minus 1.
Nope, can't do it.
It equals what? 0. So that's my y, correct? And you say there is no inverse. There's no inverse. Why is there no inverse? Because the determinant of B was 0.
It cannot equal that.
Okay? What do you want to call this matrix?
Z.
Jeremiah.
Jared.
Okay, so 1, 5, 1, 3, C. First thing you do is write it on your paper,
Yeah,
Oh.
Evan.
Yeah, and
and then I write what?
Right on this.
DETFC.
D-E-T, the what? What's the D-E-T?
Determinant.
Determinant of D, C.
C
How did I find it?
equals
1 times
1 times 3
3.
and minus a negative 1 times a negative 5.
A negative 1.
Yep.
No?
Yeah.
There's no negatives up there.
Yeah, there is. Times.
So 3 minus 5,
3 minus 5 is,
Now, if you only write this part, is that okay?
Yes.
Yes, it is.
What?
If you just write 3 minus 5,
Yes.
the determinant of C equals 3 minus 5 equals -2, is that showing me work?
Sure.
Yes. You don't have to write down all of it, but you have to at least show me that. So since it's -2, do I keep going?
Yes.
Yeah.
Yes. So the inverse of C equals 1 over the determinant, which is -2. And my rule tells me to do what now?
Take the D. You put
I switch the main diagonal, so 3 and 1,
-5.
and then take the negative of the secondary diagonal. And this -1/2 is just a scalar, right? So I just distribute that to everything in there.
Sure do.
So -1/2 of 3 is
None of those are even. -1/2 of 3.
-3/2.
Negative. Wait, no, not positive 5.
Yes, positive 5/2. Positive 1/2 and
Negative.
it's hard to slow down because is it that quick to do?
Yes.
Okay, so if we're right when we multiply the beginning matrix and the inverse, I should get what? 1, 0, 0, 1, right? Okay, so I'm just going to write it next to it so I don't have to copy it all down again. Okay, so 1 times, that was weird. Okay, so when I find the product of these two, I should get what?
That.
What matrix is that?
The identity.
The identity matrix. So I'm going to get a 2 by 2 and a 2 by 2. I'm going to end up with a 2 by 2, right?
Yes, you are.
Okay, so I get -3/2 plus 5/2,
That gives you 1.
and then I have 5/2 minus 5/2,
Minus 5/2. Let's go.
and then I have -3/2 plus 3/2, sorry, and then 5/2 minus 3/2.
Yep.
So this would be 2 over 2, which is
1.
1, and 5/2 minus 5/2 is
0.
-3/2 and positive 3/2 is
0.
and 2 over 2 is
1.
so we do it right.
No.
Okay, you do not need to check them all. I just wanted to show you that that's what happens. The whole purpose of this is we're going to be solving matrix equations. So we need to move things from one side of the equation to the other. But I told you guys we don't divide matrices, do we?
No.
We multiply by the inverses. So we're going to have to find inverses to be able to do that. Okay? Just like we don't divide fractions, we multiply by the reciprocal. Okay? So it's our way of being able to do division without actually dividing. Okay, try this one on your own. What are we going to name this one?
Z.
J.
J?
For Jeremy.
Jeremy?
Do it for
Jeremiah.
Okay.
Jeremiah. Boy.
Jeremy.
Chris Jericho.
Okay.
For Jally.
Okay, people are thinking. Yes.
You can come to the office, please, we'll be leaving.
Okay, thank you.
Are you wrong?
Shh.
2 minutes.
You got the assignment right now. Hey, how'd it go?
I got it right, Mrs. Nick.
Woo! Kale, Natalie, did you get it?
I got
Caleb?
that part. Miss
Yeah.
Nick, I didn't get it right.
For sure?
Where's the-
Yeah, I just need to like look up after that formula, like to make sure it's right.
Okay, Callie, you good? Andrea?
Yeah, I just don't know how long it's expected out of the hours.
Well, if we can check it again just to show you to do it again. Isaiah?
The multiplying, the original times the.
It's just numerator times numerator, denominator times denominator. This is 2 over 1, so 2 times 1, 9 times 1.
No, not that part.
Oh.
The original times the.
Oh, you messed up that?
No, I didn't know how to like. Yeah.
Oh, we haven't done that yet. Yes.
What do you do at, well, wait, that's checking on mine. I was
Yes.
like, I just got confused.
Garrett,
on
you
the
good?
checking part.
Okay. You don't have to check, but we'll check. Because you guys want to check, right? So we gotta take this times this, yes?
Yeah.
Yeah.
Okay. So I'm just gonna write it here. 4, 1, negative 1, 2. So 4 times that, so that would be what, 8 ninths? And then minus 1 ninth. Oh, plus 1 ninth, sorry. And then negative 4 ninths. Plus 4 ninths.
Yep.
And negative 2 ninths. Minus, not minus, plus 2 ninths. And then positive 1 ninth. And plus 8 ninths. And so I get 1, 0, 0, 1. Now, I always get the question, will it fall apart like that really all the time?
No.
Yes. Because it has to be 1, 0, 0, 1. So if you did it right, should it come out right?
No.
Yes.
Hint, don't reduce if you have to check. Like, show a step of it not reduced. Because if everything has a common denominator, you don't have to worry about that, right? Now, obviously, in your inverse, if you needed to reduce something, you need to reduce it, correct? But if I have to check it, do I want all common denominators? Yes, so just remember that you have to have those common denominators. But you do not have to do the check,
Okay, good.
okay? But it's just matrix multiplication, and should we know how to do that?
Yes.
Yes.
We're gonna have to do it on the test?
Multiply?
No.
Check. I might say prove that they are, so then if they're inverses of each other, what do they equal every time?
1,
0, 1.
I'm very upset that you did not ask me if I got it.
I'm sorry, Evan, you didn't write it on
No,
the
it's just pretty.
have it.
I knew it. It's just pretty.
I'm sorry. Did you have that?
Yeah, I did.
Good. Clark, did you have that? Austin left and it got me off track. Okay, one more. I think this is it.
We need to call it Z.
Call it,
S
S.
what she just picked wrong.
Why is it that?
for me.
For Sadoff?
For sure.
For Sheena.
For Sadoff, you mean? Hey, did you know my aunt's Shannon Sadoff? So it's for double your aunt.
Yeah.
Yeah.
Why?
Your aunt is 2 times S.
Okay, shush.
I'm helping. Squared back.
Yes, it would be S squared. You're correct.
Smarter than Bill.
Forgot it.
Bill, are you okay? No, I'm not.
You guys aren't done yet?
I just.
Sorry, I was writing.
I got it.
Shouldn't you be done already?
I just. Whoa.
You started.
No. It's 0.
Yeah, so what is it?
There is
There is no
inverse.
I was getting there. I'm like, wait, that's 24. I was thinking it was plus at first, and I was like, wait a second.
There's no inverse.
Well, actually, I was too busy looking at those are
Sorry.
the halves. And
Now, if you get a lot of no inverses, you're doing something wrong.
Nope.
no,
No.
I know my multiplication. I
You're
know.
still.
I was
Sometimes-
writing.
Sometimes we don't remember to multiply, we add. You found that out when you did matrix multiplication. I will hand you out your quizzes right in a second as soon as I stop the video. The other thing is, on 33, it just says, does it have an inverse or not? There's 4 of them. So all you have to do is find the determinant and say yes or no, but you have to show me. You can't just put yes, no, yes, no.
I'm putting.
So we don't have to show the inverse instead of the
No,
alpha
it just
or
on 33 it says does it have an inverse?
I don't want one.
Okay.
Yeah, I do.
So I am going to stop the video and then I will hand out your quizzes.
I should have. I didn't. It's not you.